I believe I am the first Brit to repair an AA5 vintage radio here on YouTube. Unless, of course, you know different. On my bench is an AA5 from the late 1950s, possibly early 1960s. That is, at present, in a very dilapidated looking condition. Enough said for the present. Let us take a look. This, the aforementioned Motorola vintage radio, model A15J3 from around 1960, is most certainly in a grimy condition. The knob pertaining to the volume and mains on off switch no longer runs true. It runs somewhat eccentric, as does the tuning knob. My guess is their respective necks have a twist or are bananaed. There is a small chip in the plastic cabinet on the top left and top right, as well as the bottom right. There are a few other smaller chips along the top left hand side of the speaker grill, and no doubt there are a few other chips that I have not as yet spotted. The back cover looks to be in decent condition. But the mains lead, being a single insulated type, has definitely seen better days. At the point where the mains lead enters the rear cover interlock, the plastic insulation has split both on the live. I believe the correct United States terminology is hot for the what we would call the live side of the mains, as well as the neutral side of the mains. I'm not sure what the correct United States terminology is for the neutral side of the mains. The copper stranded wire inside the mains lead is oxidizing, which suggests to me this wee radio has not been powered up for some decades. I'll go on to remove this back cover and see what it looks like inside. And here we have it, chaps, just the way I like 'em. Dirty and untouched. What more could anyone ask for? Looking at this board in better light, it is not as bad as it might have first appeared. It is mostly an accumulation of carpet dust. I'll remove the 5 valves and give this board to my wife to clean. Being a registered asthmatic, dust of this sort can easily trigger a nasty asthma attack, something I definitely want to avoid. Besides that, my wife does a far better job of cleaning chassis and printed circuit boards than I could ever hope to achieve. First of all, how do you all dig the piece of carpet mat here on my bench? It only cost me £1 from the pound shop. My idea is to throw this mat into the dustbin once it becomes too dirty to work on. It's certainly better than working on newspaper. I say my wife has made a good job at cleaning this printed circuit board. Yes, very good. Along with cleaning the plastic case. the two knobs, and the back cover. Yes, not bad at all. It is, all round, better to work on. A very good pal of mine, Mr. Brendan Dadle, living on the other side of the pond down in the city of Detroit, in the state of Michigan, very kindly furnished me with this circuit diagram. Though the model number A15J3 is nowhere printed on this service sheet, Brendan assured me it is, being the HS744 chassis, the correct one for my Motorola radio. Now, who am I to dispute that? My good pal has been doing service work longer than I have. For those of you who are not familiar with my repair restoration modus operandi, I always begin by looking over the power supply circuitry. In this instance I'll include the audio output circuitry also. To save time, I've checked the heater continuity of each valve by applying my Evo multimeter switched on to diode test to their pins 3 and 4. Each valve heater reads fine. Okay, what do we have here? Mains, or should I say 117 volts AC via step-down transformer from 240 volts AC, neutral AC via the mains on-off switch attached to the rear of the volume potentiometer, is strapped down to deck. The live side of the mains connects onto the 35W4 rectifier valve heater, center tapped, connection pin 6, 117 volts heads in two directions. To the right it supplies voltage for heaters V5, V4, V2, V1 and V3, which forms the heater chain loop down to deck. You will recall I did say the 117 volts AC can go in two directions from pin 6 of the center heater tap of the 35W4 rectifier valve. As the 117 volts takes a left turn, it does so via the left hand side heater section, which also neatly acts as a fuse to supply 117 volts to pin 5 of the 35W4, which is the anode, thus enabling the rectifier valve to conduct. Having taken its cut for operating, 115 volts raw DC from pin 7 passes on to C 1A 50 microfarad reservoir electrolytic capacitor through pi filter resistor R6 1K rated at 2 watts and onto C 1B 30 microfarad smoothing electrolytic capacitor to deliver 95 volts along the HT rail. C4 47 nanofarad capacitor effectively straddles the 117 volts AC input. Its purpose is to suppress mains-borne interference. I believe I've adequately summarised the general working of the power supply circuitry. Now I'll press on by doing the same for the audio output circuitry. V4 50C5 is a beam tetrode audio output valve. Pin 1 being the cathode, onto which is connected a 150 ohm resistor, is strapped down to deck. Audio coupling circuitry from subboard, it looks like K1, or it might be X1. Connection pin 6 passes through to grid 1, pin 5 of the 50C5. Grid 2, pin 6, receives 95 volts DC directly off the node of R6, 1K pi filter resistor, and C1B 30 microfarad smoothing electrolytic capacitor. Anode, pin 7 receives 115 volts DC via T1 audio output transformer off the node of R6 1K pi filter resistor and C1A 50 microfarad reservoir electrolytic capacitor. C3 22 nanofarad is the top cut capacitor, which shapes the audio tone. I also believe I've adequately summarised the audio output circuitry as well as the power supply circuitry. Now I'll begin the task of testing and replacing components within those two circuitries. Before I get stuck into fault tracing, this very sad looking mains lead will need to be replaced. This length of mains lead, which, if my memory serves me correctly, came off a Regent to an Anagram record player. Although it's grubby, it's not as grubby as this mains lead from the Motorola radio, but it will serve as an excellent replacement since it is in decent condition. It would be illegal for me to fit single insulated mains leads onto any appliance that operates from 240 volt mains. It has to be double insulated. Single insulated mains lead was no longer used here in the UK after 1975. And here we have it, chaps. One replacement mains lead ready for the use of for a Motorola valve radio around the late 1950s to the early 1960s. Whenever someone I know well is visiting the USA, I usually present them with a shopping list. This type of mains plug, along with wall outlets and black and white double insulated mains lead, etc., is not readily available here in England, and quite often they are the commodities I require. This mains plug, which is an old reversible type, is the last one of 16 brought across the pond almost 25 years ago. It still has its price tag attached to it. It costs 71 cents from a shop called the Dunn Corporation, or something like that. The print has become somewhat faded. One thing for sure, that dual capacitor canister is going to be replaced. As you will see, the original dual capacitor canister has been removed from this printed circuit board. A cursory view from the top of this PCB gives the impression these two replacement electrolytic capacitors will slot directly into place. Unfortunately, that is not so. No matter how I attempt to position the two replacement electrolytic capacitors, there is insufficient space if I use the existing holes where the original dual electrolytic capacitor canister was positioned. Drilling small holes into this circuit board is out of the question. So the method of accommodating the two replacement electrolytic capacitors will be to make a printed circuit subboard. That will be sufficiently small enough to comfortably fit into this area here, whilst at the same time sporting the two replacement electrolytic capacitors. Like some of you, I too adopt the KISS philosophy. Keep it simple, stupid. And I believe I've done exactly that here. This printed circuit, if indeed this offering of mine could be regarded as such, was done using a permanent marker pen. Nonetheless, if it does what I intend it to do, after it has been etched in ferric chloride solution, populated and connected onto the main printed circuit board, I'll let you be the judge. This power subboard, etched, polished, ready for drilling and populating with these two electrolytic capacitors. Power supply subboard drilled, populated with the two electrolytic capacitors, and the copper side coated with clear lacquer so as to prevent the print side from oxidizing. I have not coated the soldered joints with lacquer, but the underside of the board is clean and shiny, and I don't know that it's showing up on camera, but you can see the reflection. And now this board is ready for fixing onto the radio motherboard. And onto the radio motherboard this power subboard has been fixed. I had to replace this 47 nanofarad capacitor with this Philips stripy 47 nanofarad capacitor to get this board to sit comfortably, and it has been securely bolted to the motherboard with 3 6BA nuts and bolts. I certainly don't want it to go anywhere. DMC, British Motor Corporation? Nah, that can't be right. Okay. Provided all the resistors on this printed circuit board give a resistance reading that is within tolerance, which in their instance happens to be plus or minus 20%, and the audio coupling subboard is not defective. There is a specific technical name for those subboards, but I can't for the life of me remember what it is. Perhaps one or more of you out there will tell me what it is. As far as I know, British radios of similar period to this radio, or any period in British radio history for that matter, did not incorporate audio subboards. As I was saying before I went off at a tangent, should the audio subboard not be defective, nor the valves or a valve be defective, likewise the volume control and the audio output transformer being okay, I'll take a professional guess this wee radio will be functional. Since it has not been powered up for a very long time, there will be the usual dirty valve pins as well as dirty valve base contacts, and there is every likelihood the tuning capacitor will be sounding scratchy. But I expect all of those minor irritations. Should there be silver mica disease, the completion of this radio repair will be put on hold whilst I buy some from an internet website. Right, I'll valve this radio up, connect it to a 117 volts AC power source, and see what happens. I'm somewhat getting ahead of myself here. As I was saying a couple of minutes or so ago, before I embark upon revalving this radio and connecting it to a 117 volts AC supply, I will first test the strength of the rest of the capacitors and also all of the resistors. It will only be a quick superficial check over via the use of this Fish 8840 component checker. Whilst I'm on with that, I will also check over. That too will be a no frills operation. The audio output transformer and the speaker, along with the two intermediate frequency transformers. My guess is each and every one of those components will likely check out okay. The only concern I have at present, if indeed it could be regarded as a concern regarding this radio, is the audio coupling subboard. Should it test as being defective, I'm quite prepared to fabricate a replacement printed circuit board. Fingers crossed, it might not come to that. Well, all 5 resistors on this board tested well within their plus minus 20% tolerance ratings. Since there were only 2 capacitors left for testing, I went ahead and replaced them. As it happens, their value ratings tested fine, but that was no indication they were or were not electrically leaky. Before replenishing my components drawers, I always give small components, especially capacitors valued over 1 nanofarad, a thorough test, so I'm confident these 2 replacement capacitors are righteous. Whilst I had the soldering iron on the go, I reworked a few suspect joints on the rear of this printed circuit board. as well as on top. It is double-sided. Continuity checks to the audio output transformer, the speaker, the two intermediate frequency transformers, and the local oscillator transformer. Must not forget the local oscillator. Tested fine in that respect. Right, now I can valve up this radio, reconnect the speaker, reconnect the frame aerial, and power up. It should be interesting to see and hear what takes place. This radio now valved up and not before time, along with the mains lead secured to the interlock. For those of you whom it may be of interest, this mains lead came off a Region Tone Handygram record player. Pictures of them are available online, though they are nothing to write home about. Whenever I repair vintage home audio that has its original single insulated mains lead, I, as a matter of course, replace it with the usual blue and brown and green-yellow, where appropriate, double insulated mains lead. This type of mains lead is no longer legal here in the UK, but it is adequate for 117 volts AC via a drop-down isolation transformer. The frame aerial has been temporarily connected, and I've looked over the printed circuit board, so it's ready for powering up. Oh, I'll just connect the speaker wires before doing that. Right, that's that done. I'll just plug it in. Switch on and wait for the valves to warm up.
They look great in it as well, you know. It's just some people, or even the whole sports six. You can't help but sing along. Hey, you've been in charge of South Africa. What?
I have tremendous respect for Rassi. I mean, we competed for a position in this argument team, didn't get on as players, got on off the field, and had a good relationship afterwards.
Though this radio is now functioning, it will nonetheless require a few refinements. The volume potentiometer has a dirty carbon track. The tuning capacitor is dirty and it requires lubricating. The valve bases are dirty. Yep. But I'm very happy about the audio coupling subboard. That is working. And by the sound of this radio, it is working well. Right, I'll do a bit of cleaning. Then I'll get back to you.
So this evening's Europa League football.
Right, cleaning and lubrication complete.
You bring yourself, sleep with me tonight.
This radio circuit board is now ready for reinstalling into its cabinet, along with the necessary reconnection of the frame aerial, speaker, knobs and back cover. Yes, it's now coming together. And here we have it, chaps. One Motorola model 15J3 vintage valve radio, repaired, cleaned and ready to enter my crazy museum of old radios, televisions and home hi-fi.
Drum by, if I remember correctly, says Al Melgeen, or yes, it was him.
You know, that's Southampton are going for it, pushing their fullbacks right up. The two wide.
Referee showing a yellow card. I'm not entirely sure. Yes, it was. Romain was booked. So I've got that bit right. Let's see what he was booked for. Oh yeah, it was the earliest under Josh King.
The repair of this wee radio was far more straightforward than I had anticipated. It certainly goes to show one can't judge a radio by the general condition of its cabinet. There are a number of reasons why I enjoy repairing and restoring All American 5 and 6 radios. Generally speaking, when compared to a number of similar aged AC/DC British valve radios, they incorporate straightforward circuitries. Their chassis, or in this instance, printed circuit boards, are easy to access. Often they are housed inside very stylish, colourful cabinets, which often makes for a few very good looking radios in one's vintage radio collection. And there are a growing number of businesses who offer an excellent selection of reproduction parts, such as knobs, dial cursors, speaker cloth and grills, makers transfers, and much more. Provided they are furnished with ample information, and if possible the original, which might be a defective part, they will likely make reproduction parts for British radios. Often the parts are very reasonably priced. It is the shipping charges and the taxes that bump up the final price. Something to be aware of when ordering parts from across the pond. As I indicated a few moments ago, this wee radio was far more straightforward to repair than I had anticipated. To be truthful, when I came to remove its back cover, I expected the coupling subboard to be defective in some way. Having my set of printed circuit making equipment at the ready, I was both relieved and disappointed. Feeling relieved meant I didn't have to do much to get this radio working. Disappointed because there was no need to use my printed circuit making equipment. Yes, I know, I use it to make a very simple circuit board for accommodating the replacement reservoir and smoothing capacitors. I'll come back to that operation shortly. It took me a few seconds to figure out the reason for incorporating small subboards in these types of radio. I believe it was done partly for reducing production costs. It enables smaller printed circuit boards, and subboards of this type were replacement parts. Extra revenue for both the manufacturers and the radio and television service sales and centres. Therefore, it helped to keep the service techs in gainful employment. Now begs the question, why did I go to the trouble of producing a very simple circuit board? The capacitors I used were ones I had readily to hand. By the standards of today, those two capacitors are fairly large. I tried several ways of making them fit by using the holes from where the old dual electrolytic capacitor canister once stood. That was not going to happen. The holes were too close together. I didn't want to drill small holes into the original printed circuit board. The copper print was lifting off the Paxlin. I didn't want to risk doing further damage to the copper print. I did not want to use ties or hot glue to secure the two capacitors to some other part of the radio. Not only is it bad practice, it also looks an eyesore. I decided, since I had my printed circuit making equipment to hand, to knock up a small subboard for accommodating the two electrolytic capacitors. It is a secure job, it doesn't look too bad, and it works well. There isn't anything I can add about the AA5 radio circuit that has not already been said. There are a fair number of tutorials for that subject available on YouTube. Just to make sure the coupling capacitor, 47 nanofarad, was not electrically leaking, I tested for positive volts on grid 1 of the 50C5 audio output valve. My digital AVO meter gave varying spurious millivolt readings. My AVO meter 8 gave a 0 volts reading. In other words, there was no needle deflection, and that was verified by using my universal AVO meter for the same operation. Therefore, the audio coupling subboard inside this Motorola radio is working as it was designed to work. The 47 nanofarad coupling capacitor is not electrically leaking. Therefore, there are 0 volts as is clearly printed on this circuit diagram on grid 1 of the 50C5 audio output valve. Okay, what was once a very unhappy looking Motorola model 15J3 radio is now reasonably happy and working. Though there are 117 volts AC, it doesn't mean the power rating is any less dangerous than 240 volts AC. Electricity kills. If you have been viewing all or part of this video, you have done so at your own risk. Since it is around, since it is 2:10 in the morning, it is time I made myself scarce to get some shut-eye. Thank you for viewing my video, for your time and interest, that is. Don't forget to look out for my next video upload. Yours truly, Phil.